do Chapter 4, Lesson 8. And when we look at Chapter 4, Lesson 8, we're talking about prime and composite. Okay? When we talk about prime and composite, we're talking about if numbers are divisible by other numbers. And you see the word composite. What does prime mean? Read the definition for me, please, Gabe. Oh, it's hard when our book's not out, isn't it? I'm on page 106. I will wait for you. Prime, 106. Read the definition for prime number. Top of 106. 106. There you go. Top. Yellow word. Has exactly two factors, and those two factors are going to be 1 and itself. Okay? So whenever I look at the number, we'll take the number 5, for example. When I think of the number 5, I have to figure out if this is a prime number or a composite number, and the way that I do that is I have to think about, does it have any factors? Remember, Leslie, factors are two numbers I multiply together to get that number, right? So are there any two numbers I can multiply together to get 5? I can multiply 1 times 5, right? So 1 times 5 would be a factor pair. Are there any other ways with whole numbers that I can multiply to get 5? No. Since the only factor pair is 1 in itself, this is considered to be a prime number. Okay? So 5 is considered to be a prime number. Can you think of any numbers less than 10 that would be prime? Which means they only have factors of 1 in themselves. 2. 2 is a prime number. It only has 2 times 1. 7 is a prime number. It only has 2 times 1. I'm sorry. 7 times 1. 3 is a prime number. It only has 3 times 1. We could use 1, but we don't typically think about 1 as being prime nor composite. I guess it's more prime than it is composite. But I don't break my numbers down to 1s, if that makes sense. Itself times 1 would get you a prime number. If it only has there is no other way, Gabe, to multiply two whole numbers together to get 5. Besides 1 times 5 or 5 times 1, right? Okay? There is no other way in the world to get 7, a product of 7, besides taking 1 times 7 or 7 times 1. Understanding that associative property or commutative property tells me that I can take 7 times 1 and that's the exact same thing as 1 times 7. Doesn't mean it has two factor pairs. Okay? Factor pairs have to be different numbers. So, any number that only has factors of 1 in itself is considered to be, at least one person said it, prime. Okay? Thank you for listening. So, when we think about numbers that are less than 10 that are prime numbers, 2, 7, 3, 5, those are all prime. Can you think of any numbers that are larger than 10? 11. 11's prime. The only way I can get 11 is 11 times 1. 13 is prime. The only way I can get 13 is 13 times 1. 23 is prime. 19, 17, 31, 37, 131. 98 is even, so I know it's divisible by 2. Okay? Shh. So, any number that only has factors of 1 in itself is considered to be, you have to know that, because we're going to use prime numbers in our prime factorization trees. Okay? Any other number is considered to be composite. Okay? And composite means what when I look at the definition, Emily? So when I look at the number 36, if I think about factors, two numbers that I can multiply together to get this number, tell me two numbers I can multiply together to get 36. I can do 9 times 4. What? I'm getting 36. 12 times 3. 6 times 6. 2 times 18. Okay? And we could also do 36 times 1 if we wanted to. But do you notice how this has many factor pairs? That makes 36 a composite number. It's composed of many factors. Many factors can be put together to give you 36. Okay? No. Yes. Every prime number will be an odd number. But that doesn't mean that every odd number is prime. For example, Gabe, 35 is odd. It's not prime. Okay? Because I can do what two factors? I can do 1 and 35, right? How else can I get 35? I could do 5 times 7. Okay? So, listen when I say this. All prime numbers will be odd, but not all odds are prime. Okay? How do I know that a prime number cannot be even? What's my divisibility rule for 2? Any even number is divisible by 2. So then I would have a factor of 1 times whatever the number is, and then 2 times another factor to get the number. Okay? So any odd number is the only one. If it's an even number, it cannot be prime. Yes. Besides 2. 2 is the only even number that can be prime. Because it's such a low number, it only has 2 factors, one in itself. Okay? So, prime versus composite. Composite has multiple factors. Prime only has 2. One in itself. Okay? Now, why do we have to know that? I know you're dying to ask me that question. Di, you may be just a minute late today, but that'll be okay. Why do I have to ask that question? Or why do I have to know prime and composite? Because I'm going to do prime factorization trees today. Okay? And what that means is I'm going to have a number like 24, and I'm going to break it down by factors. Okay? When I look at, please pay attention. Okay? When I look at 24, please know that we could use 6 times 4. We could use 2 times 12. 8 times 3. It does not matter which pair of factors I start with. I could start anywhere I want. Okay? But do you see how we have this first little branch here? Do you remember these from last year? Okay, so we have this little branch here, and what this branch is going to tell me is it's going to tell me that I'm going to have 2 factors at the bottom that are going to multiply together to give me the number that it's pointing to. I'm going to use the factors of 24, so I could do 6 times 4. Okay? The goal, what I want to do with a prime factorization tree is I want to factor my numbers all the way down till I get prime numbers. When I finish, I want to have a row of prime numbers at the bottom. Okay? So when I look at 6, is 6 prime? No. What two numbers can I multiply together? Besides 6 and 1. What two numbers can I multiply together, Pierce? 2 times 3. Okay? Is 2 prime? Absolutely. Take it to the bottom. Notice my multiplication sign follows. Is 3 prime? Absolutely. Take it to the bottom. Is 4 prime? No. 4 breaks into what? 2 times 2. You already told me 2 is prime. You already told me 2 is prime. Notice the sign follows. Notice between each one of these numbers is a multiplication sign. So if I was breaking 24 down into my prime factorization, this is what my answer would be. I can then order them from least to greatest. So I have 2 times 2 times 2 times 3. And all I did is I put them in order from least to greatest. Okay? When I get to the bottom, I want to have all prime numbers. Okay? So, let's look at another one. Let's do 48. I want to show you one more, then I will give you one to do on your own. When I do 48, does it matter which factor pair I start with? No. Do I want to start with 1 and 48? No, because then I'm just going to have to do 48 again. So I'm going to start with 6 times 8. Actually, we'll start with 12 times 4. Okay? Is 12 prime? No, because it's even, I know it's divisible by 2 at least. Okay? What do I want to break 12 into? 6 times 2? Okay? I continue going down the same side of my tree all the way till I get to prime numbers. If it works easier for you to then come over here and look at 4, you can do that. Okay? Yes? I know. We're going to continue with this side. I typically go all the way down one side first. I stopped here so that I could tell you, you can come over here and do 4 now, but you have to understand that you would have to come back and look at 6 again. Does that make sense? Okay, so Emily was jumping the gun a bit. She said, but I know 6 is composite. What two numbers can I multiply together to get 6? 2 times 3. Carry down your multiplication sign. Emily also told me that she knows this 2 is prime. I'm done with this side. Okay? Now I have to look at 4. 4 is 2 times 2. I know that 2 is prime. I have to carry them down along with my sign. All right. Here's the real kicker, folks. Ready for it? I can go ahead and I can reorder these. 2 times 2 times 2 times 2 times 3. How do I know this answer is right? What should I be able to do? If you had to guess, what should I be able to do? Alexa, what do you think? Ha! She's a genius. If I take 2 times 2, I get 4 times 2, 8 times 2, 16 times 3. I was going to say, you may not know off the top of your head, but it is 48. So when you break this down to these bottom figures, you should be able to multiply them out, and it will give you the original number you started with. Okay? Hold tight for just a second.